This is the first video in section 1, and in this video we're going to look at integers, integer properties, and absolute value. So we're keeping things pretty basic right now. Let's get started. So in order to talk about integers, we first have to look at natural numbers. What are the natural numbers? Well, these are the natural numbers. Should be a very familiar set. It's the set of counting numbers, starting at 1, counting up by 1, 2, 3, 4, 5, 6, and so on, going on to infinity, right? That set of numbers are what we call the natural numbers, and we denote them with this symbol here. It's this special looking n. Yeah, those are the natural numbers. Before I move on, I do want to quickly point out these curly brackets are just notation telling us that this is a set of elements. A set is just a collection of objects. In this case, we're looking at a collection of numbers that are all grouped together. You group together all of the counting numbers from 1 up to infinity, and you get the natural numbers. Okay? If we add 0 to that set, we end up with the set of whole numbers. Okay? Whole numbers looks a lot like the set of natural numbers, but with a 0. Unfortunately, they don't get their own symbol, but you can still do a lot of cool things with whole numbers. For instance, you can make a number line. A number line here, we're starting at some point 0 and extending the line infinitely. Here I have it extending in the right direction. Then on that infinite line, you can put points for all of the natural numbers. You order the natural numbers from least to increasing, right? Least to greater. And that gives you this number line right here. And it's a pretty useful visual aid. You can automatically see anything that's to the left is going to be less than anything to the right. So I can see clearly that 2 is to the left of 3, so 2 is less than 3. Whereas 3 is to the right of 2, so 3 is greater than 2. So it's a helpful tool, but this number line is a little limited. It's only extending infinitely in one direction, right, in the right direction. Conceptually, what that's saying is that since this line goes on forever, there is no greatest number. There is no greatest natural number. You can always find a number that's greater than any number on this line, right? And that should make sense when you're counting to infinity. But when you move to the left and you start looking at numbers that are less than, you do eventually reach a stopping point. It stops at 0. So 0 is our least number in the number of in the number line of whole numbers, right? Conceptually, this is saying, of course, 2 is less than 3, 1 is less than 2, 0 is less than 1, but nothing is less than 0. And I think that's true in some cases, but in math, we often want to expand our framework for how we view things. So if we reach a point where we're saying there's nothing less than 0, we can respond by saying, well, why don't we create a whole class of numbers that are less than 0? You do that by adding in the negative numbers. Look something like this. So now what we've done is we've extended the number line infinitely in the left direction. Essentially, you can think of that direction as moving towards negative infinity. And as you move to the left, you're still getting less than, but we're moving less than 0. We have -1, -2, -3, -4, -5. So now we have numbers to the left of 0 and to the right of 0. Everything to the right of 0 we'll call positive. These are our positive numbers. And everything that's to the left will be negative. One thing to note here is that the negative numbers are basically a mirror image of their positive counterparts, right? So we have natural number 1, and then we have -1. We have 2 and -2, 3 and -3. So